In today's video, we're gonna talk about 10 facts that you probably didn't know about BIM and BIM software. Number 10, BIM is not a software. BIM is not a tool or software package, but a process and an approach supported by various tools and software packages. At its core, BIM is a process that allows architects, designers, urban planners, and any professionals involved in the creation of buildings and infrastructures to create digital designs that capture all the information of the real-world buildings. BIM goes beyond geometry and simple 3D modeling to capture the metadata, behaviors, and relationship between components on a building. The components themselves are not simple abstract forms, such as those proposed by old CAD software. BIM software gives you a definition of each element, such as a wall or window. In addition to the 3 dimensions, it also incorporates other dimensions such as cost of materials and time. The BIM process allows architects and designers to build intelligent models that can manage all the information related to a building across a life cycle, which is really interesting in my opinion. Number 9, BIM is not new. While the practical implementation of BIM is recent, its widespread adoption is an ongoing process that existed as a concept since the 1960s. Thinkers and designers already imagined using computers and software to help in the design and specification of a building or an infrastructure project in a way that could be easily accessible and modifiable by its users. Unfortunately, the technology and computational power of the time prevented it from becoming a reality, as BIM software not only advanced in computing power but also in graphical user interfaces, 3D graphics, and databases. The 1970s saw a great deal of innovation in the computing field and also the start of practical implementations of BIM. In a paper titled "The Use of Computers Instead of Drawings in Building Design," Charles Eastman put the foundation of the modern BIM system. The proposed prototype, called BDS or Building Description System, came after some years and many iterations of Building Information Models or BIM. Number 8, Rucaps was the first BIM software. The 1970s saw the appearance of the first batch of CAD software, which paved the way for BIM software.
And then of course we can turn off the Rucaps grid. This is an example of more symbolic information, dimensions. This is just a little test model that we've put together.
It is very hard to pinpoint precisely the first BIM software, as many of them saw the light of day around the same time, but in the academic circles, Rucaps is regarded as the forerunner of BIM software.
You're taking very talented, skillful people and you're giving them a whole new set of skills and tools to work with. And then what you learn as you work with computers feeds back into how you approach architecture in a very positive way, because it's just another thinking process and you begin to learn what debugging is about.
Rucaps, or Riyadh University Computer-Aided Production System, was initially developed by Dr. John Davison and John Watts during the 1970s and the 1980s. They took their work to GMW architects, who sold many hundreds of copies in the 1980s when CAD software and the hardware to run it was limited and expensive.
I think we're pretty much dedicated to always trying to bring the higher levels of computer applications to the architectural profession, and there's a lot to look forward to in terms of what's coming our way, in terms of massively parallel computers that'll speed up this kind of processing and give us the ability to walk through it and visualize it in real time. But we're not there yet. We've come a long ways. And Rucaps users originally were prepared to invest anywhere from $200,000 to $400,000, $600,000 to get these systems. And now with the advent of computer systems like the DEC Microvacs 1 and 2, we're able to put these kind of systems into offices for as little as $80,000.
Rucaps was a 2.5D interactive system, concentrating on the rapid production of 2D drawings, and it paved the way to many modern BIM software that came after it. Number 7, the 80s was the gold rush of BIM. Almost all the household names in the BIM field saw their initial software release, or at least created a company during the 1980s. Rucaps was the first, followed by Sonata and Reflex. The French Dassault Systems revealed CATIA version 1 in 1981, and the following year Autodesk was founded, in addition to Graphisoft by computer programmer John Walker and Gabor Boyar respectively. In the year 1984, Bentley System was born, and a year later they released version 1 of the MicroStation software. In addition, the year 1985 saw the release of the first version of Vectorworks, a software that would be acquired later by Nemetschek Group, a BIM company that also has another popular BIM tool which is called Outplan, launched in 1984. Revit, the most popular BIM software today, came very late, and this took place in 1997. Originally developed by Charles River Software, and it was acquired by Autodesk in 2002. In my opinion, this is actually a pattern in history that clearly shows that being first does not mean you will be the best or the most popular. For example, Apple is not the first computer company, and Microsoft isn't the first company to create an operating system. Number 6. Archichad is the first modern BIM software. Archichad deserves a place on this list because Graphisoft was the first to introduce a BIM software able to create 2D and 3D geometry on commercial off-the-shelf computers, and this took place in 1987. The other BIM-capable software that were available before were either university projects, proprietary in-house CAD programs, or required very specialized hardware out of the reach of most people. Today, Archichad is one of the major BIM tools on the market. With more than 30 years of development, it is a complete design suite with 2D and 3D design tools in addition to drafting and documentation features, parametric modeling, lifecycle management, and a host of other features that makes it suitable for a wide range of applications from building to urban planning. Number 5. BIM was standardized into an ISO. Because of the importance of the architectural field and the pivotal role that digital documentation plays in the business of building and infrastructure management, BIM was standardized into an ISO, namely ISO 19650. This ISO defines the BIM on an international level as following: the use of a shared digital representation of a built asset to facilitate design, construction, and operation processes to form a reliable basis for decisions. In addition to defining the BIM process, it sets out the recommended concepts and principles in support of management and production of information during the life cycle of a built asset. Number 4. BIM software have an interoperability problem. One of the major roadblocks of a wider BIM adoption in the industry is the problem of interoperability and flawless information transfer between BIM applications. Due to the diversity of vendors' backgrounds, many have created proprietary data structures in their software which are incompatible with others. A data file representing a door, for example, will work in a given software or suite, but not in another vendor's application, which is a problem. That's why Building Smart, formerly AAI, the international organization tasked with creating and improving data exchange formats and standards, with the goal being the implementation of neutral, non-proprietary, and open standards for the BIM field. Building Smart has already published many standards such as the IFC, AECXML, and Kubai to make exchanges easier. Number 3. It was Autodesk that popularized the term. Looking back at it, the first generation of BIM software were actually named Virtual Building Applications, which is a nice name and not hard to remember, but also generic to a certain extent. The name BIM, or Building Information Modeling, was not yet popular as we know it today till 2002, when Autodesk released an article with the name Building Information Modeling. But this wasn't the only reason, because other software vendors started asserting their involvement in the field and the term was popularized. Number 2. There are 4 levels of BIM. It is actually generally accepted that there are 4 levels of BIM, namely 0, 1, level 2, and 3. This represents the maturity level of a building information model, which has different and certain criteria. Level 0 is only using 2D CAD with no collaboration, either distribution on a paper or digitally. The next level is level 1, which is using a mixture of 2D and 3D models and 2D construction documentations. On the other hand, level 2 is where every team member works fully on their 3D model and the models are exchanged showing in open standards such as COBie or IFC. Finally, level 3, which is still being fully defined. It is where every designer is collaborating on a common shared model within a unified BIM process, which also includes clients and shareholders. Number 1. BIM has a bright future. BIM is a relatively new technology, but an important one nonetheless. It's advancing at a very rapid pace, both from technology and regulation standpoints. The most important area of focus now is interoperability and standardization. The goal of using a shared model will imply using various technologies such as cloud computing and a solid layer of cybersecurity, using perhaps blockchain technology for secure authentication and data protection. Other advances are in the area of 3D, such as virtual reality and 3D scanning, LiDAR technology and 3D printing, which still need to find a place in the standardization process, along processes such as environment footprint and energy modeling. Needless to say that now with the rise of automation, parametric modeling and AI, no one can predict the path of BIM because only the future can tell. I hope you found this video useful and informative. If you have something to add, please leave it in the comment section below. Also, you can check some of our previous videos. Thank you very much for watching, and I'll see you in the next one.